All right, if I'm looking at these, key thing right here is not replaced. If it says not replaced, what does that mean?
Dependent.
Dependent. If it's dependent, that means what happens on the second one is affected by what happened on the first one. The first one you do like normal. What would the probability of a red be right here?
3 over 16.
3 out of 16. All right, but here's the difference. So we had 16 and I took one out, but I didn't put it back in there. So now how many are left in the bag? 15. So that means the new number on the bottom is going to be 15. It's not going to match the 16 like it did before. Like when we did the cards a minute ago, it was 52, 52 every time. It's not going to be that way when you're doing dependent. So then you say, well, how many greens are left out of that 15?
5.
And 1 over 16.
You get 1 over 16. All right. So if I go to the next one, all right, yellow. How many yellows are there? 2 out of
16.
the 16 that we started with. Each problem starts over. Well, I know the new denominator is going to be what? 15 because I took one out and left it out. Well, how many reds are still in there?
3.
1 over 40?
Yeah.
All right, give me the next 2. So blue and red. How many blues I got?
6 over 16.
And 16 total. Then it's going to go down to 15 because I did replace it. Red ones, there's still 3 of those in there. So I'd multiply that out and get.
3 over 40.
All right, go to yellow and not blue. Well, yellow is 2 out of 16. All right, not blue.
10.
There's 10 of them that are not blue out of the 15 that we have left. All right. All right, how many is that?
12.
Oh.
How much?
12. 1 over 12.
All right. Go down to red and red.
Oh, damn, man. Man. Oh.
If I'm looking at red and red, well, I know it's got 3 reds out of 16, and I know it's going to go down to 15. All right. I had 3 reds, and I took one of them out. So how many reds are still left in the bag?
2.
There's only 2 for the second choice. Because I took one of them out to start with. Everybody get that? When it's the same color, the top number is going to go down too. All right. All right. So this winds up being 1 over 40. All right. Do the green and green right there. All right. So green and green. How many greens do we have to start with?
5.
5 out of the 16 total. On the second one, what happens? There's only 4 greens left out of 15 total choices. And that becomes 1 over 12, is that right?
Yeah.
All right. Blue, red, and green for the last one. How many blues are there?
6.
So I'm going to say 6 out of 16. Red,
3 out of 15.
and then green.
5 out of 14.
5 out of 14.
There's only 14 left on that.
Oh,
You had 16, took one out, that's 15. 15 took one out, leaves 14. The bottom number's got to go down by 1 each time. All right, what's that answer?
3 out of 12.
All right, so 7 and Jack. I'm going to do the 7 first. How many 7s are there?
4.
Out of 52. Well, now there's only how many left?
51.
And how many of those are Jack's?
4.
Still 4. Answer?
51. Oh,
4
4.
over 660.
663.
3.
That can't be
3.
right.
Yes, it is.
663.
Yes, sir.
All right. So it couldn't be 662. Why?
Okay, you can subtract.
4 and 662 would simplify.
Oh.
All right, queen and then less than 4. So queen is 4 out of 52. How many are less than 4?
12.
There's 3 in each group. So that's 12 total. Out of 51. Answer?
4 over 222. 221.
4 over 221. All right. Black and then the red. Well, black is 26 out of 52. Red is 26 out of 51. What do we get?
13 over 51.
All right, an odd red, and then an 8. How many odd red cards are there?
How many rock? How many? No.
Odd red.
I mean 26.
Odd red. The aces, the 3s, the 5s, the 7s, the 9s. There's 10 that are odd and red at the same time. Times the 8. How many 8s are there?
4.
There's still 4 of those left out of 51 total. My answer is
I got a race, don't
10 over 663.
say again.
10 over 663.
10 over 663.
3.
All right. King and a king. Well, how many kings do I have to start?
4.
4. Now, when I take one king out, there's only 3 left for the second choice out of 51. That's going to be 1 over something.
1 over 221.
How much?
221.
Not a 7 and then a 7. So how many not 7s do I have?
How many not 7?
Yep. 48. I know that there's going to be 51 left after that first choice. So then picking a 7 the second time.
48.
4.
4.
I'm going to say there's only 4 7s left in that deck. All right, what we got? Yeah. What's my number? 16 over 221. And then the last one down here, 6, and then an even. How many 6s do I have?
4.
Out of 52. And then even, how many even numbers do I have?
1, 2, 3, 4, 5. 5.
4,
26.
8, 12, 16, should be 20.
And you still count the 6
Mhm.
because because the 6 is, does that matter?
Count what?
Is that counted twice or not?
No.
Good question. All right. Again, on this one right here, since we already took out the 6, that's one of the even cards. Instead of 20, that would be 19, is what I'm thinking, but I'm going to double check that and make sure. So give me the number there if that's right.
19 over 668.
That? I'll have to double check that one, make sure we did that one right. All right, so if I'm looking at this, this says the probability of A given that B happens. Well, you notice it equals the probability of A. Independent means what? It's by itself, it's alone. In other words, the fact that B happens has nothing to do with what happened to A. A is going to be the same regardless of what happens with B because it's independent of it. Here, the second one says probability of B given that A happens. Well, this got to equal the probability of B because what does the A have to do with B if it's independent? If it's independent, nothing. It's got nothing to do with it. So that's what these first two are saying is probability of A given that B happens. Well, it doesn't matter. It's got to be what A is. Well, this one's saying probability of B given that A happened. Well, it doesn't matter what happened with A because B is completely separated from it. All right? And then the probability of A and B happening would have to be those two things multiplied together. If you can show one of those things is true, then you know it's independent. If not, then it's got to be dependent. All right, get that. All right. It tells me that G is going to stand for taking math, H is for taking science, G and H taking math and science at the same time. Then it gives me the probability of each one. In order for me to show that it's independent, I've got to show one of these things right here. Right? If it gives me all 3 parts all I'm gonna check is the first one times the second one equal to the and part? Well, I don't have A's and B's, I've got G and H, but I do it the same way. I'm gonna say that, well, here's gonna be my A. This G is my A, so that's 0.6. Well, let me do this. So instead of the A, we're gonna have G and then H so I'm just replacing the A and B with G and H, but we're doing this exact same thing. So probability of G is 0.6 times the H, which is 0.5, and I'm going to see if that equals the 0.3. If these two things equal each other, then it's independent. If not, then it's dependent. All right, so check that for me. What's 0.6 times 0.5? 0.3. So I get 0.3 equal to 0.3. So what does this mean when they're the same?
Independent.
That means independent. If these two numbers wind up being different, then it's dependent.
How you multiply that?
All right, so what you need to do on these to get it worked out is to figure out what it's asking for. So in this case it says probability of female and long hair.
0.45.
So that's what I need to have. Well, it's got to equal the probability of being female times probability of long hair. What is female and long hair up there? 45%, which is 0.45. Probability of just female is 60%, which is 0.6. Times probability of long hair, which is 0.5. You wind up with 0.45 equals 0.3, which means they're not the same, which means
Dependent.
dependent.